So this one, we're asked to find the mass of a droplet, and we're sort of given quite a bit of information in a similar way to previous questions, but we're missing some crucial details. Just to be aware, in the actual question on the handout, you are given the density of oil is 960 kilograms per meter cubed, and you're given the viscosity of air that's eta, and they don't tell you it's eta. That might be to avoid giving you too much of a clue which equation you need to use. So 1.8 times 10 to the negative 5 units, Newton seconds per meter squared. So we're given that information in the question. And until you have that, it then becomes you may think it's actually sort of quite hard to get started. You can have a look at this, and we end up with this equation from Millikan's experiment. So we've got the QV over D as mg, and that's not going to get us where we need to be. We need to be using F equals 6 pi eta RV. So the force when it's at terminal velocity is 6 pi eta RV, and that's going to equal the weight. So they're going to be equal in magnitude. Now, the mass of the object, the mass of the oil drop is 4/3 pi r cubed, which is the volume rho g, and you'll notice that changes to that cancels to a 2, and that cancels out there, and the pi's cancel as well. So we end up with, just to tidy that up, we end up with 6 lots of eta v equals 4/3 r squared rho g. Now we're going to be able to work out r because we know rho, we know g, we know v, we know eta. We're going to work out r, and then we're going to use that to work out what the mass is. Okay, so we've got rearranged for r squared. So we've got 6 eta v over rho g, but then I need this fraction on the other side, so I get 3/4, and then I can solve for r squared, and I get that 6 lots of 1.8 times 10 to the negative 5 multiplied by 1.15 times 10 to the negative 4 all over 960 times 9.81, and then that's all multiplied by 3/4. And that gives us an r squared value of 9.9 times 10 to the negative 13. So r equals the square root of that, which is 9.95 times 10 to the negative 7 meters. So now I've got that value, I can work out the mass. So the mass is 4/3 pi r cubed, and that equals 4/3 pi 9.95 times 10 to the negative 7 all cubed, multiplied by rho, this rho out there, at 960. And we end up with it being 3.96 times 10 to the negative 15 kilograms.